Welcome to the final part of this module, where we will study the application of remote sensing in agriculture. The application of remote sensing in agriculture, i.e., in crops and soils, is extremely complex because of the highly dynamic and inherent complexity of biological materials and soils. However, remote sensing technology provides many advantages over the traditional methods in agricultural resources survey. The advantages include capability of synoptic view, potential for fast survey, capability of repetitive coverage to detect the changes, low cost involvement, higher accuracy, use of hyperspectral data for increased information. Below is a summary of these applications. Crop production. Forecasting. Remote sensing is used to forecast the expected crop production and yield over a given area, and determine how much of the crop will be harvested under specific conditions. Researchers can be able to predict the quantity of crop in a given farmland over a given period. Second, assessment of crop damage and crop progress. In the event of crop damage or crop progress, remote sensing technology can be used to penetrate the farmland and determine exactly how much of a given crop has been damaged and the progress of the remaining crop in the farm. Third, crop identification of pests and diseases infestation. Remote sensing technology plays a significant role in identification of pests in farmland and gives data on the right pests control mechanism to get rid of the pests and diseases on the farm. The crop data collected will be taken to labs where various aspects of crop, including the crop culture, are studied. Fourth, crop acreage. Estimation. Remote sensing has also played a very important role in the estimation of the farmland on which a crop has been planted using survey sampling. This is usually a cumbersome procedure if it is carried out manually because of the vast sizes of the lands being estimated. Soil moisture estimation. Soil moisture can be difficult to measure without the help of remote sensing technology. Remote sensing gives the soil moisture data and helps in determining the quantity of moisture in the soil and hence the type of crop that can be grown in the soil. Sixth, soil mapping. Soil mapping is one of the most common yet most important uses of remote sensing. Through soil mapping, farmers are able to tell which soils are ideal for which crops and which soil require irrigation and which ones do not. This information helps in precision agriculture. Seventh, monitoring of droughts. Remote sensing technology is used to monitor the weather pattern of a given area. The technology also monitors drought patterns of the area too. The information can be used to predict the rainfall patterns of an area and also tell the time difference between the current rainfall and the next rainfall, which helps to keep track of the drought. Eighth, yield. Prediction. Crop yield prediction is the process of estimating the potential or expected yield of a specific crop for a given area and growing season. It involves analyzing various factors such as weather conditions, soil characteristics, crop genetics, and management practices to make informed predictions about the likely harvest. It is important to note that crop yield predictions are subject to uncertainty due to the complexity of agricultural systems and the influence of unpredictable factors like pests, diseases, and extreme weather events. Farmers' Edge scientists and researchers combine these data sources with the most recent advances in machine learning to update yield forecast estimates whenever a major yield component is disrupted. Preseason data. Preseason data must be accurate to lay the groundwork for crop yield prediction. This information is available before the crop is planted, and it lays the stage for the first yield prediction readings. Data such as a field's location, current and previous crops, field-specific weather months before planting or seeding, soil test information and data, and regional weather trends over the last decade are all combined to provide insight into how to start the season with accurate yield numbers to anticipate. In-season data. In-season data provides insight into variables that affect farm yield throughout the growing season after the foundation has been laid. Farmers' Edge on-farm weather stations give field-centric data that enhances these datasets by delivering expected and predicted values that are stored and then reset when data comes in each day, advancing the models. Other in-season data, like fertilizer application, is also taken into account during the season, whether planned or not, to improve field diagnostics and offer forecast yield values. Crop-specific data. Farmers' Edge agronomists have identified crop-specific data that impacts yield during a growing season, including water content during major growth stages, or hours above cardinal temperatures for crops during key yield-determining periods, for the 5 main crops in yield prediction. corn, canola, lentils, soybeans, and wheat. Crop and field imagery. High-resolution satellite imagery is used to set NDVI crop health values on fields fast and precisely, allowing researchers to look for erroneous results or regional concerns with crops that could affect yield. These regional trends can be used to determine if areas are on track for forecast or whether environmental factors have distorted the crop yield prediction values. Histogram data. Farmer's edge yield. Prediction models use big statistics to find different distributions in field images over time, which then offers clarity to a convolutional neural network that can use these modifications to forecast yield across large areas, such as the United States or Canada, as imagery changes over time. It's not simple to anticipate production before the harvester runs through the field, but the Farmer's Edge team provides producers with farm yield predictions based on complete and accurate statistics. We have come to the end of this module. Join us as we explore other modules together.